Okay. In the work, energy and power chapter, today our topic is energy. What is the meaning of the energy? Basically, we can say that it is the ability to do work. It is the ability to do work. This is the energy. And we know that energy is required, or it is required to develop a force. Develop a force. If you want to develop a force, then we require energy. But one thing we have to know again, this if you want to classify the energy, there are two type of energy we can say. Energies can be classified into two ways. I am writing here. Energies can be classified into two categories. One is, we can say, kinetic energy. Kinetic energy I am representing as K only. Yes. What is the meaning of the kinetic energy? We know that due to the motion, the energy occupied or energy carried by the body is called the kinetic energy. We can say, what is kinetic energy? It is due to the motion of body, the energy possessed is called kinetic energy, we can say. And the kinetic energy is equal to, we know, half mv square. This is the formula to find the kinetic energy, we can say. Second one is the potential energy. What is the meaning of the potential energy? Potential energy is the stored form of energy in a body. Stored form of energy which is used to do work. What is the meaning of the potential energy? Potential energy is the stored form of energy which is used to do work. In this way, we can classify the energy into two categories. One is the kinetic energy, second is the potential energy. But except these two type of energy, we are having also different type of energy also. That is the dissipated energy. If you want to understand the dissipated, it's a very important topic. If you want to understand the dissipated energy, first we know that work done means what? Work done. If we talk about the work done, this work done means, we can say, this is the transfer of energy. Work done is nothing else, it is the transfer of energy. Whenever we want to do some work on a particular body, then what happens? The energy is transferred to that particular body only. So that is why I am writing here, work done is the transfer of energy. Okay. Due to this, whenever we want to, this transfer of energy is, due to this transfer of energy, the energy can be classified into three categories again. One is the kinetic energy. Transfer of energy, either it can transfer in the form of kinetic energy, or it can be transferred in the form of the potential energy, or it can be transferred in the form of the dissipated energy, or we can say that energy is lost to surroundings in the form of sound, light, heat, etc. I can write. Yes. In this way, we can say transfer of energy can be transferred in the form of kinetic energy, in the form of potential energy, or we can say that some energy can be lost to the surroundings in the form of sound, light and heat, etc. But whenever the energy is lost to the surroundings, this energy is called the dissipated energy. I am writing in this way. This is called the dissipated energy, or this is called dissipated energy. When this energy is dissipated or it is lost to the surroundings, it cannot be retrieved back to the system. It can't be retrieved or retrieved back to the system. Are you getting this point? It means, what is the meaning of the dissipated energy? Basically, the energy which is lost to the surroundings in the form of sound, light and heat, etc., that is called the dissipated energy, and it cannot be retrieved back to the system. But now, if we want to take an example for the dissipated energy, example, friction force, or the work done by the friction force. Suppose I am taking an example here. Suppose this is the surface of the any rough surface I have taken. This rough surface is the rough surface, and this rough surface is having some coefficient of friction. That coefficient of friction I am taking mu, and here one body I have placed, and this body is having some mass. Suppose that mass I am taking the small m, and one force is applied on this particular body towards right. We know that when we are applying the force on the body towards right, this body will displace, or this body will move from this place to the another place towards the right direction. So in this way, suppose after some time it reaches to this point, and here the body reaches. After that, suppose one thing we can say that here if the surface is the rough surface, then we can say that if this is the direction for the intention of motion of the body, in the opposite direction of the intention of motion of the body, one friction force will be applied, and this is the friction force, it is applied towards left only, because towards right the intention of motion of the body is there. That is why the friction force will be applied in the opposite direction of the intention of motion. That is why this is the friction force. Again, we know that if you want to write work done by friction force, it will be how much? That work done I can write this F into S. So suppose the displacement covered by the body is S I am taking, and here we can say that the work done by the friction force will be that work done W I am representing as W. So W is equal to, I can write friction force into displacement, because friction dot displacement I can write. Both are in the opposite direction to each other. That is why here theta will be 180 degree. So we can write Fs cos 180 degree. So cos 180 value is -1. That is why I can write here simply minus Fs. Again we can write this friction force is equal to mu into n into S is there. S I am writing. N is what? If this body is having the some mass m, then we know mg force will be acted in the vertically downward direction, and as a result this surface will apply a force on this particular body in the vertically upward direction, and that will be called as the normal reaction and capital M. So in case of n I can write mg, so this can be written as W is equal to minus mu mg into S. This is the work done, we can say, by the friction force, and due to this work done will be converted into the energy, and this energy is a loss of energy. It is lost to the surroundings. It is lost to surroundings. Yes or no? It is lost to the surroundings. So we can say that this is the one energy we are getting, which is produced due to the friction force. This is the one example for the dissipated energy we can say. Yes? Okay. In the next class we will discuss about the conservative force, or on the based on this particular transfer of energy. There are two types of forces. One is the conservative force, second is the non-conservative force. In the next class we will discuss. Okay.